Uh, Thanks, guys. Uh, Actually, it's evening on a Friday, not on a Friday, evening on a Thursday, and everyone is packed here. And I think it has been a tiring day from the last 2 days. So I'm thankful to you guys who have been here. So today we'll talk about how we really went around with the Databricks journey within Zalando. We have been using Databricks in Zalando for around a year, more than a year, and it has been quite a rapid adoption at Zalando. So first, I'll just start with the boring slide. And the reason that this starts with boring slide is just to get you out of the sleep. But the other thing is that to really focus on what do we really think about software development. It's a very collaborative exercise, but ideally the goal for that should be something which is very positive. Things like this are positive, and that's what we are here in the room for. Now I introduce my company. So Zalando, if you have been buying shoes and clothes on Zalando platform in Europe, you must be knowing about it. We were founded in 2008 in Berlin. This is currently leading online fashion portal across the Europe. We define ourselves as a starting point of fashion and as a platform which can connect our customers and brands. And one thing when you talk about Europe is that it's although it started in 2008, but it's not a small company. We are present in 17 countries, and we have a massive scale. So we are not at a scale of Amazon, but quite a very big scale of having more than 1,000 million visits per quarter already, with 80% of the traffic going on mobile, and with monthly active customers being more than 26 million. Now, when you talk about this, the big challenge that really comes with Zalando at this scale has to be in data. And that's what when we started in 2008, we started with one data stack to another data stack. We do have a legacy footprint, but we also are very active in open source. So a lot of Zalando contribution has been in open source, and we will continue towards that. One of the very successful product is based on Kafka. This is Nakari. This is an open source API on the base of Kafka platform. This is all treated both as an enterprise bus and as a streaming platform as well. Apart from that, we are also working with managed services and enterprises like Databricks for different use cases. And one of them we'll talk about in detail regarding Spark. So about us. So I'm Akhil. I'm the product manager in data solutions. I've been working with Zalando for around more than a year. I actually come from a finance domain. And there's my Saurav, who's a co-speaker here. He's a data engineer with more than 9 years of experience, and is actually holds a master's from National University of Singapore. Now, when we talk about data platform, specifically I'll focus on the data platform, which is based on S3, AWS S3. For this data platform, what we have done is we had a company-wide OKR of actually making all the data within Zalando available in our S3 platform-based data lake. So we do have a wide variety of data sources, and there are ingestion pipelines, and they are being ingested in data lake. And a lot of AWS, a lot of microservices are based on AWS, so the data is already there in S3 as well. And this is something which we started around a couple of years back. We thought it's a very simple problem, and then we just had some Presto clusters on front of it, and we made it available to data scientists in the form of Jupyter notebooks. We also made it available to business users or ad hoc users in the form of Superset, MicroStrategy, etc. However, obviously, this multi-tenant thing doesn't really work out of the box for every use cases. And there are some practical use cases. One of the practical use cases can be as simple as that some team wants this data, but that particular data source is yet not ingested in data lake. There might be a data pipeline which is planned for next quarter. So that can be a simple use case. There can be another complicated use case. For example, the data is in data lake, but just it's not fresh enough. And this can be as a thing like somebody really want to build a streaming application, so that building a recommendation system, and wants latencies or freshness to be something which as a central solution based on S3 ingestion pipelines don't work for them. Or they can be a team which just wants to process something right back to data lake so somebody else can use it. Or any n or m number of use cases where a team is dependent on data processing done already by some other team. Now, if you see this thing, this is actually a requirement for a wide variety of use cases for quite a compute requirement. So a compute requirement can be that some team really wants an auto-scaling, some teams want to have their own language of choice, some team wants stream, some team wants batch, and some teams want to do some machine learning training on the top of it. Now, this actually comes to a question of this, that should we have a lot of, should we treat this problem as an organization problem, or should we treat this problem as a data or as a technological problem? And what I mean by it is that, do we really think about central services or like a common department, or do we really think about a decentralized way of doing it? And in Zalando, we have been doing a kind of hybrid approach to it. But there are problems if you do it in a decentralized way. So the biggest problem is actually cost control at scale. So you can have argument from from another department based in another city that as per their cost centers, their AWS cost is pretty good. But when you are doing this thing, the big challenge is that a lot of times the effort and the data is replicated, and this increases the cost. And you also have a more time to production because you have a lot of dependencies. You may have a lot of dependencies over each other. And this is really true for microservices world, where although we always say that, do one thing well, and the challenge with the data is that it really doesn't stick with that way. And a lot of data platforms, a lot of data that we are talking about is still in some kind of monolithic way. So this creates a problem in terms of dependencies and also technological problems like inconsistent environment, different versions of Spark, etc. And another big problem from a developer perspective is that it lacks community knowledge. If you are doing things differently in a different environments, without a community support, this is difficult, and this is sometimes goes as a data silos within the company. I have written the word accidental complexity as the last bullet point here, and I talk about this as an accidental, not as an essential complexity, because what we believe in is that this is a manifestation of decisions that an organization takes over the course of implementing their data platforms. So we have tried to do it by replacing a part of it with Apache Spark as a unified engine for use cases ranging from streaming, auto-scaling, etc. We are not really talking about here use cases like high-frequency trading. We are not even talking about very so-called real-time use cases of 100 milliseconds, because those use cases are rare, but definitely present. At this time, we are really talking about very general use cases across a horizon of Zalando, where we are using Apache Spark as a foundational piece of our big data infrastructure. We are working in a kind of centralized model in which we are supporting teams and helping them self-service. We are using GitOps as a way of helping them instead of building an abstraction on the top of Databricks for our sister teams. And when I talk about teams, the teams in Zalando, there are more than, I don't recall the number, it's around 300 to 400 tech teams already within Zalando. This also helps us to present this environment as a compliance and as a centrally controlled security CI/CD way of doing things and putting the guardrails in practice, so that if you are at a scale like Zalando, what you really care about is at scale is two things, which is security and compliance to standards. And we should think from this perspective that we should never think security and compliance is something which is stopping innovation. And that is the reason that having this solution as a central service really helps us here. We have a lot of clusters and jobs currently running, and more than 18, or more than actually around 20 teams in production using Databricks at the moment. We are one of the biggest customers of Databricks in Europe at the moment. And the biggest win for us has been a thriving Databricks community within a year within Zalando, with more than around 500 people participating in this community, sharing knowledge with each other. We also have an active support from Databricks, and I'm really thankful to my colleagues in Zalando and Databricks for helping us with this asset of community knowledge in Zalando. We are also using Spark for other use cases like migration projects. Example, moving a lot of ETLs from Oracle to Spark-based S3, and also to projects where we need some kind of traceability, and where we are, and here also we are using a lot of structured streaming. We are actually a big adopter of Delta Lake. We were using Delta even before it was open sourced. And making Delta open source really helped us. And now actually, we talk about what kind of use cases we are solving in Zalando. So the best thing about Databricks is that it actually helps us solve a variety of problems, from payments to marketplace, and helps us to solve a problem in other business units which are within Zalando group. I will invite Saurav, my co-speaker, who will go into details about some of these use cases, and then we can take this forward.
Thank you, Akhil. So as Akhil already mentioned that we have a lot of use cases. Here we will focus on few of them based on their maturity and based on their adoption of Spark and Databricks inside Zalando. So the first thing is GDPR and antitrust. I think most of you, or almost all of you, would have at least worked on it, or would have at least heard of it. So this is a real problem that we need to solve, and a lot of companies are solving it in different ways. So here we are presenting a subset of the approach that we use inside Zalando to make us compliant with GDPR and antitrust laws. So one more thing I want to say is that we have a lot of data regarding partners and brands. So these laws are, antitrust laws and GDPR laws are very important for us. We not just do data deletion, but data segregation also, because we have data for all the brands and partners that communicate with us. Okay, so before going into this, describing what we have written here, I want to talk about what are the file formats that we use in this. So today we are going to focus on the bronze data sets, as Databricks call it, which for us are the JSON data sets. We have more than 5 petabytes of data from 10 years worth of data in JSON data sets. These are semi-structured data sets, very hard to query, very hard to search. So if it is Delta or Parquet, obviously now as Databricks Delta supports updates, upserts, it's pretty easy to do that. But in case of your bronze datasets or the first datasets that come into your system, how do you search in that? When you have to be compliant, you have to remove the instances of users for all the datasets that you have. So the first approach that we use is as an engineer, what you will think. So as a customer, if someone calls the customer care, they say that, okay, I exercise my right right to be forgotten, and you have to remove all my data. So let's, for simplicity, we assume that email ID is the ID or identifier that we use inside Zalando for identifying a customer across different data sets. So the first thing as an engineer, what we have to think is that we cannot go ahead and do a query on 5 petabytes of data. It's ridiculous, and it's like 3,000 data sets that you have. Even with Spark, looking for just one field which you don't know, you'll have to deserialize each JSON format files and then look into it. If the record exists, it cannot be done. So as an engineer, the first thing that we need to do is to probe, to limit our search. So how do we reduce the amount of data sets that we traverse? So what we came up with is something called a probe. So let's say you are the first customer that came up with this. So, and we have to solve it. So what we do is that we use a marker event. We emulate the user, we emulate his interaction, so that all the data sets that get affected by that marker, or all the data sets that can have that marker, when later searched, says that, okay, these are the data sets that can contain the user data. So in this way, what you're doing is that you're exploring across all the 3,000 data sets, but you are only doing it for 1 day's worth of data. So your overall data set becomes very small. So in this case, you can create a heat map of all the data sets, or the traversal of the user data from different data sets. If it is like joining of two data sets or two events happening or something like that, and then you create a list of all these data sets. Data sets here, I mean just the event names or the S3 prefix that we have. As we go later, now you have the list of data sets with you. Most probably, not all of the data sets has PII data. So you have already gotten rid of around 80% of the events that are there. So out of 3,000, you're left with around 500, 600 odd events. Now in these events, still you have to go and search for that particular field. Now using Spark, if you want to do it, you can do it. You read it and you remove that particular field. You search for it. You remove that particular field and you write it back. But Spark writes on partition level. It doesn't write for individual fields or individual files. And as I mentioned, these are bronze data sets, so there are a lot of small JSON files also which are present. So in this case, what we do is that we use Spark for parallelization, but then we use also a S3 capability, which is S3 inventory, to get the list of all the files that were created after the user was first created in our system. So you already have a list of files which you can actually loop through, iterate through, and then stream per file to check for the presence of that particular data. Once you have that, you can do an in-place replacement using S3 client, and you use Spark just for fanning out your S3 clients. So in this case, what you have done, you are not overwriting the full partition, and you're also not breaking the downward readers. So there are different engines who are consuming this data. So you're not breaking them because it's an in-place replacement. You're just skipping the record which has been written on that file. You can even keep the file name same. So in that case, even the downward readers would not break. So this is the first thing that we came up with. The second use case I want to talk about is, this is back, okay. The second use case that we want to talk about is search and ranking. So it is basically the relevant article ranking that you have to present to users when they search for something on Zalando website. Everyone is doing it. Everyone does personalization. So why it is different or why it is difficult? So it's difficult because of the scale at which Zalando operates. We have more than, like Akhil already mentioned, we have over 1 billion visits last quarter itself, and we have over 1 million active articles that we have. And at the time you'd make a search, we have to go through all the articles that fit into that your search results, and then we have to reorder it to personalize it for you. So we have our colleague sitting from the search team here, so he can go into more details if you have any questions later. So as a user, when you go on the website, on Zalando website, and you search for something, so what are the two things that we care about? How can we personalize it for you? So the first thing is that we have to identify you. That is the user session that we create. And the second thing is that the articles that come into your search results, we have to personalize it for you, so it has to be reordered. So as you can see that the machine learning model that we train here or create here is actually using these two inputs. The first one is the session. So we create a user session model, which is like the page views and your interaction, your impression on the pages. And the second thing is the article data. So the article data is actually coming from the data team pipeline that we have created, the serverless pipeline, in which we use Nakadi, which is an API abstraction over Kafka queues, and it's the whole serverless pipeline of Lambda, SNS, and SQS, which then very seamlessly integrate with the Spark streaming job that we have in Databricks. And then we write it as delta table in article updates, which is then later used for training. One thing to mention here is the feature engineering. So there are around 200 features of articles. So the training that happens, which is, by the way, taken care by or lives in the life cycle of MLflow, has so many features, so many features that you can use while training this model. And then these models differently are later used to do the article ranking. So this is the page where you actually go and search. As a user, you search for something, you have the search results, and then there is an article score. This article score comes with the article update stream. We have over 4,000 updates happening per second, which can be anything from the availability or pricing changes, or based on size or colors. So there are so many. Like I told you, there are 200 features. So based on this, there are 4,000 updates happening per second. And we use this data, we feed into the model to do the article scoring. When you make a search, the search results are first returned, and then it is joined with the article scores to finally render it to you on your web page. So a lot of things goes behind it. Now I'll move on. So these were the two things I wanted to go into details, but there are other use cases also. These are in the early adoption phases of Databricks inside Zalando. One is sizing. So a study shows that most of the 70% of all the returns that happens on e-commerce platform is based or due to sizing or fit issues. So the research team, sizing and fit research team in Zalando is trying to solve that problem. Right now, they generate KPIs using Databricks platform, which in turns, they build KPIs for the ML models or algorithms that they have created. We also have a second use case of experimentation. So experimentation, again, it's the internal product experimentation. And it's just because of the scale, it becomes so hard, because there are over 1,000, every day, over 1,000 experimentation results that or analysis that happens over the day. And this can be, and each analysis can go more than 35 TBs of data. Then we have merchant analytics. So as you know, we have brands and partners, and they want to time and again see how their articles are faring in our system. So we have this team, merchant analytics, that crunch that data on Databricks, and then put it as a report, or put it as a portal, which is then shared to the partners. Then we have marketing service. This marketing service is based on the campaign data that brands have with us, and this team is also crunching the data to find out if how the campaigns fared over time. So next, those were the use cases that we had. And now let's talk about the first impressions that we had of Databricks. So initially, since we are the central team, and we are responsible for making Databricks available to the whole company in a compliant manner. So GitOps was one of the few things that we did in very early stage, and it bared fruit for us, because it's very seamlessly integrated with the continuous delivery platform that we had, and all of the users that we have, mostly like data scientists, analysts, or data teams, or even BI engineers, they are very well versed with GitHub. So they can just do a PR, and using continuous delivery platform, we will create all the infrastructure that is required for them, and they are up in no time. Second is the multi-tiered support system. So in Zalando, Akhil already talked about the community that we have, the chat system. And as the users grew over the year, like a community, they started helping each other. So initially it was us, but then the whole community took over, and it's now, even if we are not there as a central team, it functions very well. The second thing is the office hours. So office hours was a very nice idea to interact with the individual team, because their use cases were sometimes not very simple, that can be fixed over chat. So they booked office hours with us. We used to discuss their architecture, because they did not have the expertise as like if you're a data scientist team, you don't have to worry about the infrastructure or the pipeline, how the data is coming. So In that case, in office hours, we used to talk about the individual use cases of the users as well as all the architectural decisions that they used to make. And we gave them the best practices, how to do it, because we used to manage that. The third is the guest developer. So a lot of BI teams, and a lot of teams you would have already had in your organization as well, that they want to go live very quickly because there's always an urgency. So there's always something like Black Friday coming up. So what they do is that they come to us, they have to go live pretty fast, and they come to us, they want us to help them. But obviously, since they have to take care of the pipeline later on, we introduce this guest developer in which one of the developer will come and sit with us. We will teach him, we will help him kickstart his project, and then he can go back and teach to his team. So this also bared fruit for us, because we taught a lot of guest developers who came and just learned few things from us as data engineers, and they were like BI engineers or just starting with Spark, and then they went back and they shared that knowledge. So we don't have to, we were not engaged with all of them, and it was like a B tree. So the third thing is the Delta adoption. So initially we faced some problems for Delta adoption, but after it became open source, we have faced none. A lot of vendors are also coming and creating readers for it. So in our ecosystem, it would be fine later on. Communicating pricing downstream. So like we said that we have a lot of teams, more than 70 teams who are currently using Databricks. So it's very difficult for doing the price attribution, who is using what. So right now, a feature something like AWS Cost Explorer is missing in Databricks, but I'm sure that they're working on it so that later on the prices can be shared back to the user, because each of the cost center, they want to know how much they're using. Exploding usage is good, yes. We started with nothing a year back, and a few months where there were just few teams, but then we have more than 70 teams now, more than 400 users. But this also has to be tagged with the cost attribution and transparency, because unless until that is there, still means later on we'll have a lot of things to think about. Fits all size. Yes, so like I said, we have around 70 teams working with Databricks right now, and it ranges from research issues, research problems like sizing and fit, to just scaling issues. So yeah, right now it's fitting well, but as the adoption increases, as they try to move all of their workload or machine learning platform over to Databricks, we'll learn a lot about it in coming days as well. So yeah, so that is that. Thank you so much.
Thank you, Akhil and Saurabh. Thank you so much. I saw a lot of pictures being taken, so that's obviously a mark of a great talk. So thank you very much for coming to talk to us today. Do we have any questions in the audience? I'm going to run around with a mic so it's on the recording, so thank you.
Hi, great talk. I have a question about data quality. So I want to know that Zalando has data quality. What kind of data quality problem you have? Probably it's like data is delayed, or it's duplicate, or is there some data missing? For example, you're supposed to receive 1,000 rows, but actually you got 999, but it's hard to detect. And what kind of tools you use for solving this data quality problem? It could be like analysis based on the scripts or dashboard, or it could be like some software and engineering, end-to-end test, those things. Could you please share us something with this?
Yeah, so not only in Zalando, overall in industry, data quality is a very active problem which is being solved. So even Amazon is solving using DeepQ. They have developed an engine for it. At Zalando, we are discussing this problem and trying to essentially solve this problem in a multi-pronged approach. So we do not have a central solution for it yet. However, we are using things like so anonymization is obviously is also, so data governance is also solving a problem by first anonymizing the data. Apart from that, we are also having projects where we are so-called creating gold standards in a streaming way. And there we are solving the data quality problems during the right time, right? And we are tying those projects very close with the BI teams, so that the data, not only the data quality is maintained, it is essentially very correlated with the data ownership. For other data which generates from microservices, like events data, or which is very difficult to find governance on the top of it due to shared ownership or something like it, we might have a technological solution like DeepQ to solve that problem. But I still always say that data quality, when we think about machine learning, is more like a data validation.
Any other questions? No? Okay. Sorry. Sorry.
Hi. Could you say a bit more about your experiments with the low latency type of data science that you've been exploring with Databricks?
Sure. So one of the, so I'll just touch upon one. There was a talk by Sebastian from Zalando today, and it was regarding creating integrated data sets within Zalando for integrating sales data sets, actually, which combines a lot of event streams. There, the latencies, I would not call it a low latency, because what we are looking is minutes only, like 15 minutes or maybe 5 minutes as a sales data latency is available within Zalando. And I think the search use case, which Saurav touched, and Danilo is just sitting beside you, is also a pretty low latency use case. Apart from that, there are teams which are working in the digital experience or search functions, which are also low latencies, but at the moment they are using a different infrastructure at place.
So just to add to it, like data lake is currently most used as an analytical system than a transactional system. So there are a lot of machine learning use cases or training that goes on top of it.
Awesome, thank you. And one more?
Could you explain a little bit better the search use case? So do you write the scoring into Elasticsearch, or do you use the Elasticsearch sorting to resort before you show to the user? So
okay, should Danilo? Yeah. Okay. So we have a data scientist who actually was there.
Well, it's a long story here, so I'm glad to take this question offline. Maybe we can talk after the talk, so we gain more space to that.
Wow, this was a good answer.
Okay, so it sounds like that's it for questions. Again, thank you so much, Akhil and Sora, for coming to visit us. If you could please remember to rate this session on the app, and let's all give Akhil and Sora one big round of applause. Thank you.